the button.
Lesniak.
I pushed the button.
You're on.
It was more impressive than
I want to push the button. You're on.
Yep.
Liza, I'm leaving you for a week.
By the way, we're on.
Are you going on it?
Hola.
This is.
Oh, hi, camera.
In February.
Now, that doesn't mean act up.
No, it's later in February.
You're gonna miss all of this.
What?
You're gonna miss all of this birthday.
Why is everybody born in February?
February is actually the very month to do that.
Unplug. When in doubt, turn power on.
Amen.
When in doubt, turn it off.
All right. No.
It says good morning, Jack.
He told you. So this is the final part where we went through naming ionic compounds. Remember, you're going to have to figure out, we're going to practice these today in class, and you're going to have some more practice for homework on Friday. Make sure we start getting these prefixes in your name, because once you get to things without, again, remember, do not see a metal. The chances are like 99% chance it is a, go ahead and shut that one, please. It is a covalent bond. Now, the one time that's going to be not the case is when you have ammonium salts. Ammonium, NH4 plus, doesn't have a metal in it, but it is a positive charge.
Got that right.
Good, I'm glad. Just remember, if you do know a common name and you're starting to accumulate these in your notebooks, for instance, we already know water, we already know ammonia, and we already know methane. Then we went ahead and had this like acid one, and again, naming for acids is not going to be tested at this time. You do have the note though. So here's the important thing. All of our polyatomic ions are ending in ATE. So that means you're going to have drop the ATE ending and add the OUS ending. So IC ending, not the OUS ending. OUS is for ITE, sorry. So the ATE ending of the polyatomic ion gets the IC ending, sulfuric acid, acetic acid, carbonic acid, so on and so forth. All right, excellent. That brings us to lecture 7, chemical reactions. And this is what you just saw. And we've already started out with a bang.
Let's go.
Can we do it again?
Yeah, can we do it again? 'Cause, like, I feel like
We will do the Hindenburg again.
Wait. Today, wasn't it?
Yes, not today.
I light it on fire.
Now, I know for the people here, that was percussion. You should have felt it.
Oliver didn't think it was impressive.
Look at the, I thought it was quite impressive. That was a good Hindenburg.
It was like a little
Probably gonna do the
mushroom
outside
cloud.
one
That's
today.
pretty cool. Yeah, we're
Yes,
doing that.
if, I might have videoed that one. If you video it in super slow-mo, that fireball is really, really nice, by the way.
Can I do that next time?
It looks like it liquefied onto the cabinet.
Yeah.
Well, oh, there's the big piece. I was looking for the big piece. It didn't liquefy onto the cabinet.
I mean,
The reason it's stuck is because as Emma and Charlotte saw, it was very, 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 very moist. Wet. It was wet.
No,
Now, we're going to find out why. It's not a big deal. That's what we're doing today. That's why we did this reaction. All right, moving on. A process in which one or more substances converted to one or more new substances with new chemical and physical properties. This is not a new note. You already know this from our matter organization notes. Your matter organization notes told you that when you get a chemical change, you actually make new stuff.
Yeah.
Does anybody remember the drastic example I gave you guys for the chemical change?
How long ago
What
was
was
that?
It was burning Bennett's.
No, Burning Bennett's notes were his quiz or homework. What was it?
It was his
It was
homework.
a lab report.
Yes, Burning Bennett's lab report was pretty good.
Was it the skill in the cup?
That was actually really good. But that's not the very drastic one I gave you.
Can we do another dissection?
The salt on the table.
Well, it was the salt. So, in other words, can I lick sodium? It says
Sure.
red. Please don't do that. Can I lick chlorine? It's red. Please don't do that. The reason is.
But what if I did?
The reason is that. Oh my gosh, Sophia, what are you doing?
My cat fell and everything fell.
All right.
My cat fell.
Like, bro.
Don't throw this morning. I had to catch her.
Sodium metal, if you were to eat it, would probably blow up in your mouth. Not probably. It would blow up in your mouth.
It's like better.
Well, I would survive.
It's
Hey, yo.
sodium metal.
Oh,
Chlorine
metal.
gas, if you were to breathe it, it actually fixes the hemoglobin better than oxygen. You would die. So these things individually would cause you a great bodily harm. But yet, after the chemical reaction of sodium and chlorine, they make table salt, which is something you eat in everything. So please notice, when you have something new being formed, it has new chemical and physical properties. Table salt is much different than sodium and much different than chlorine by themselves. In fact, it's a necessary compound for us to live every day. Yes, Bianca?
Can we do pop rocks and do the science behind it? Why pops?
Can we eat pop rocks?
Pretty easy, it's just trap
Can we
gas.
do pop rocks?
No, I'm
Alright. Does anybody know this reaction just by looking at it and naming these elements?
I feel like I've seen
Photosynthesis.
Iron. Steel.
Very good.
Yes.
This is rust.
Oh, that's. Hey, I was pretty
kind of
close.
close.
Oh, aren't the.
The game.
That's kind of, yeah, we're speeding up the process over there.
Um,
Rust is being made when iron reacts with oxygen in the air.
I say.
Now, we can tell an iron nail is something that can hold two pieces of wood together. Oxygen is something we breathe every day. But yet together, they make this reddish, powdery substance that really won't hold two boards together, and you certainly don't want to breathe. So, I'm hoping this draws the point. Also, notice the states of matter change here. Iron is a solid, it's a metal. Oxygen is a gas, and the end result is an ionic compound, not a metal nor a gas, and it's an ionic solid that's red in color. So, again, I hope these are good examples, they're everyday examples that you see that, wow, when a chemical reaction happens, new substances are formed. Excellent. Now, here's the problem with chemical reactions. These are very easy notes. I'm not going to hardly explain them.
No.
Okay, I'll go back and let you get them down. You do need to know what reactants and products are, but you should know that already from previous classes. So just get them down. I'll give you a moment to write them in.
I was just about to grab a notebook.
You should already have your notebook out.
We were taking a test.
That was a 10.
Like 10 minutes.
Oliver, I think I might have to be switching your seat.
That's crazy.
You might be a front row Joe.
Don't do that to us, please. No.
Yeah, I says don't do that. Last chance, Oliver, then you move.
I'm trying to find it. My backpack is a
No. This is your last chance
Meaning.
I love that game.
for you to be acting in this manner. We're going to act as if we care.
Just pretend it is.
Yeah, if you don't, then you need to pretend, at least in this class.
Just finish reacting.
Did anybody, as you see these notes, again, I'm letting you write them, I'm just asking this question over top. Is there nobody in this room that have not seen these words before? I don't think I said that right.
Yeah, we've all seen it before.
Okay.
Thanks for seeing the live hat. That might be something.
Well, Junior, I know you have. There are a couple new students this year.
I wonder.
I spoke on your behalf. Yes. You have a question? I thought I was gonna get a chance to teach.
Man.
You teach. A.
It's an article.
Oh, yeah.
It describes it so you can come forward.
This is an English class, bro.
I found the thickest dictionary and there are 4 definitions of A.
I bet you.
It was like took up a whole page.
Single
I mean,
sides.
I know they don't spell it the same way,
Tell me your
A,
high
but
school without telling me your own.
Canadians use A all the time, eh?
That's spelled differently though.
Hey, I said that. Hey.
Hey.
It's confusing.
We're definitely done the note.
Wait!
Not done. We started singing Christmas carols.
Guys, we're recording.
We were just so excited.
This recording is gonna be great.
We were just given a little.
Y'all just don't have the Christmas spirit.
It's November 12th.
If I wasn't recording, I would show you that I'm making the ultimate holiday song list.
So like they
I'm up to 31 songs
Uh-huh.
that have made the Lesniak cut.
Is it on like
Wait, play it.
Not yet.
We're recording.
Wait, that's a special surprise?
Spotify?
Oh.
It's even better.
This is gonna be the
Amazon.
greatest video.
Let's go!
Can you send us a link? Post it in the Compass,
I guarantee you it's all.
Compass
Make
YouTube
it
channel.
Yeah, make it Compass Chemistry YouTube Christmas playlist.
It's gotta be all Mariah Carey.
Right,
It's just saying
Here's
periodic
a-
table.
here's an issue that we're gonna see. There's already one issue on the page. No one has said anything yet, but that's okay. I don't mind that. And there's another issue with this one. So right now we have 2 chemical reactions that you've seen in your notes. The one that's currently on the board and this one, iron and rusty. Somebody tell me what the reactants are in this formula. Yes.
I mean,
Iron and oxygen.
And somebody tell me what the one product is in this formula. It is rust. Very good. And on the board, the one you're copying down currently, what are the reactants?
Sodium,
sodium,
chlorine.
Correct. And what is the product?
sodium chloride.
Table salt. Excellent. So this is how a chemist will represent a chemical reaction. They use these symbols and they write them out. Reactant goes to products. Yay! Make sure you use the correct symbols. I already have issues on many of these polyatomic ion quizzes. Why?
On the
symbols. Because the symbols are wrong. You're doing lowercase letters. And there are lowercase letters on the periodic table, but those are actually different, like they're different elements. So if you write PO4, I know that's phosphate. But if you write PO4, that's polonium.
Well, I feel bad for you.
So
Oh, that's
we say uh-oh.
That's okay. Hey, I mean, tried to do the right.
Okay, it was meant to be uppercase.
It was meant to be.
Well,
It's either uppercase or not
Never,
uppercase.
So,
RXN is a reaction.
using the correct symbols are very important.
Is RXN reaction?
RXN is the shorthand for reaction. Please make sure you make note of that. Because RXN means reaction. And if you... Reaction. Rexin? Rexin.
Sounds like a medication question.
Who can tell me the 7 diatomic molecules without looking at the periodic table?
A, B, C, D, E, F,
You can?
1.
All right, who can tell me them looking at the periodic table?
Nitrogen. Oh.
Nitrogen.
Wait, that was one?
Chlorine,
Phosphorus.
iodine,
And what?
A, B, C, D, E, F, G.
I got boron.
Iodine.
Who said hydrogen? Good. It's hydrogen.
There.
Who's iodine?
Only when they are by themselves. I put this note in here. I yell it out in class. Only when they are by themselves, because here's what I have people do. I have people put a 2 by every time they see hydrogen. No, hydrogen can be like, especially, we've already seen sucrose in this class, H22. But when they are by themselves, they are diatomic. Please
I
note,
think-
chlorine by itself,
What do you mean
Diatomic.
by itself?
not
By
bonded
itself.
to another thing.
By the definition of a pair, there are two of them, so it is not by itself.
Okay.
I'm gonna throw something at you.
Okay.
Oh my
It's
god.
a little bit of table.
Over this though.
What's the
You haven't heard of some math.
Those are commas.
Let's see. Oh, thank you.
They separate different things in a list.
Got it.
Man, I'm doing some grammar today.
No, I couldn't see in this table.
I'm just saying, I'm really confused by the businesses.
By themselves.
Themselves. Ah,
By
I see.
It's all written on her.
As in the
Oh, are
element.
we stressing you out?
Correct. No stress.
Oh!
I am stress free.
Sorry, the timing was funny. I said, are you stressing? You said correct and you're saying him, but I thought you meant yes.
Emma.
No.
Dang
Can I go after?
it. Let the line begin.
Yeah, can I go after?
I'm trying to get through 3 slides.
Can I?
And you have to go through
Yeah, go now.
I don't actually need to, I just want to ask. Man,
All right,
the one
and of
time he
course-
actually says yes is when I don't.
No, wait.
What? That's,
Go back. I missed the last one.
that's just 2 elements by themselves. That's not even a necessary note.
Oh, okay.
Is this a new slide?
And this is the final
Wait,
slide.
go back.
Oh, today?
No, that was unnecessary. You already have it in your notes.
Okay.
I don't know.
You guys are so, I would love you, this is the same due diligence I want you to do at night when it comes to studying.
No.
Go back, there was 3 words I didn't see. Go
No.
home and have that same
No.
desire.
Well,
All right, balance in chemical equations. We now have seen 2 chemical equations. Here's the other chemical equation we have seen. And we finally get to this note. And it's due to conservation of matter. Here is what was not stated. And believe it or not, in 20 plus years of teaching chemistry, I would say, and that's because I did it by semester early on, so we're talking 30 chemistry classes roughly. So through 30 chemistry classes, I would say maybe 28 of them were like you, didn't catch it, didn't say, wait a second, didn't say, whoa, that something's wrong. The few that did said, hey, wait a second. There's 1 iron here and 2 there. There's 2 oxygens here and 3 there. There's 1 sodium and 1 sodium. That's good, but there's 2 chlorines and 1. So, something's wrong. Why is something wrong? Because we already know this law of nature. Who can recite to me the conservation of matter or mass?
Matter cannot be created.
Base times height.
In any chemical process.
Matter cannot be created or destroyed in any chemical process.
Base times
That
height.
means that the total mass of the reactants must be equal to the total mass of the products. So something's amiss here.
Can I go?
Is she back?
I am back.
We are, how about this, Sophia? Just so you know, I'm gonna just inform you. In a roughly like less than 10 minutes, like 5 minutes, we're gonna be in a practice zone and you'll not miss any instruction. Or you can go now.
She can't wait.
If you can't wait, you can't wait.
I'll be fast.
All right. Well, currently what we have written on the board, this is not right. And so this means we have to balance the chemical equation. Whoa!
Ah!
It died on you.
And the best way to do that, ladies and gentlemen, is make the number of atoms equal on both sides. If the numbers of atoms are equal on both sides, then the mass must be equal. And therefore you will be following the law of nature. And I do hope you realize that you do have to follow laws of nature.
No, dang it. What do you mean I can't fly?
I can fly.
You can try.
No, we're not going down this road. This road is a bad road.
Stop it, stop it. He can fly.
Splat.
She was fat?
Oh, right. Wait.
I stand corrected.
A chemical equation that exhibits the law of conservation of matter is called a balanced chemical equation.
Oh my. I can't spell.
So many notes.
There we go. Problem solved.
So many
We added 2 more. 3 more.
Keep up, Oliver. Keep up.
He writes so fast in English class.
I don't have passion anyone in here. It's just unintelligible.
I hate people that say that. I'm not gonna lie.
Oh.
Whoa, whoa,
Oh. That was freaky.
whoa. I'm sorry.
It's like an evil laugh.
Hey.
Wow.
Now, if you were here 4 years ago
Nope.
4?
I was.
with Mr. Lesniak as your science teacher,
Oh, I hated
We
these.
had like 7 different teachers. Oh.
Yeah,
not
true.
that year.
6 or 7.
That was
Wait, so it'd be
Oh,
3
that
years
was that
ago.
year. No, it was 4
Yeah,
years
it
ago.
was.
What?
But first semester, I was completely here as I gave them their time to find a reliable science teacher, which I know they did.
We
Did not.
About that one.
Get
So,
like a new teacher.
but
Yeah,
at that time, we did balance simple chemical equations. Does anybody remember at all what we did
I failed that quiz.
in order to balance the chemical
I have to
equation?
check Martin.
We
put it on a scale.
Is it
Remember with exponent?
close?
Isn't it like the one
That's
with,
square root the number.
isn't it like the one with chemicals?
Is that where we had
Is that the one that Berkeley hated and started
Yeah,
dying?
the one-
Yes.
Oh,
Oh,
Yeah, I remember that one.
I don't.
Everyone's like the one
Now
Berkeley
we're
was like
yeah.
so pissed
That is
about
the
it.
one that Berkeley, I think she did shed a tear.
She's so mad. Yeah.
She did not like balancing chemical equations.
Who did?
Oh, most everyone got a hold of it.
I
All right,
liked it.
here's what you did not realize that you're going to realize now is that there are actually numbers in front of these. In fact, right now, if I were to talk about these as atoms, you're talking about one atom reacting with one molecule of oxygen to form one formula unit of rust. In other words, we assume the number 1 in chemistry almost 100% of the time. And again, we realize this because if it wasn't anything, you wouldn't have put it up there.
Yeah.
So there are actual numbers here. And these things are called coefficients. And these coefficients can be changed because you're just changing the amount of something. And so here's what I will tell you, that the math will always work. Why? Because you got to follow laws of nature. This one atom of sodium and one molecule of chlorine to make one formula unit of salt.
So put a
We can change those all we want because we're not changing what happens, we're just changing the amounts of what happens. 6 and 7. All right, here we go. How do we change this to
So
get
you
these
need to
things
put a
out?
2 at the NA and a 1 at the CL.
All right, a 2 on the NA, 1's assumed.
Okay, then done.
No, it's not done.
No, it's not.
I mean, it's close enough.
It's close.
A 3?
Negative
Two.
Ah, now watch. If I count on both sides, I now have 2 sodium atoms. I now have 2 sodium atoms. But this is connected. So if I have 2 sodiums, I also have how many chlorines?
2.
That's good, because guess how many chlorines I have here? 2. We're done. That is a balanced chemical equation.
Oh, would there be a 3 in front of
Nothing.
Oh,
That's
there's nothing.
done. Now, let's go up here.
Should I need be?
Because you can't multiply 2 to 3. You have to do 3 times O, and then how do you have to?
I think there's a 5
I would
in
put a
there.
4 in front of FE.
4 and then the
3.
I think there's a.
Wow,
Never
that's a good one.
Because you
4 irons,
simplify it down again.
4 irons.
Oh.
6 oxygens, 6 oxygen.
Fine, that's fine.
No,
time. That's fine. 3 times
Multiplication.
2.
The 2 is like a.
Oh wait, no, this is good. If I have 3 of these, it is multiplication. So O2, O2, O2. Now add all those up.
302.
So that's good. We got to get that down. There's no adding when we're changing coefficients.
It's like
That's
an
distributed over.
Exactly.
Well, just be careful. It's called a coefficient.
What is in the number?
All right, excellent.
This is
Now, these are the rules for balancing, by the way.
1, 2.
We already did that one.
Why are we crying?
Wait, no, I'm not crying.
There's no.
I'll come back to that one.
So what's the super awesome thing?
Yeah, can we get on the super awesome thing?
Yes.
Wait,
Oh, I can't wait.
for you?
All right. These are the rules / tips, and they're going to be very important for you this week. 1, once a compound is written correctly, you cannot simply go in and change a subscript. You cannot change a subscript once a compound is written correctly.
What if I want?
Now, if you've written it incorrectly, you might need to change the subscript in order to write it correctly. But it is vital that you can go in here and just change these things. Okay? And 2, you can only change the coefficients to balance the equation.
If you change the subscripts, you can just change them all at once.
That's right. And the coefficients are the number in front of the particular substance. If you didn't know that already.
Really?
And this is our final slide for the day. But we're going to be doing lots of practice today, so it needs to stay organized. Oh, today's been a good day. We blew stuff up. We took a quiz. We had a little lecture. Now we're going to have practice.
Oh, the fun. Wait, what about the fun thing?
Oh, we do have to do the fun thing, but I'm going to leave that until the very end.
What about the
Oh,
fun
come
announcement?
on.
You can't just leave us off like that. That's the fun thing.
No, I really do think this is this could be somewhat game changing.
Oh, wait, for real?
Game changing.
So we're gonna
Yes.
die?
Are we getting it free like 10 times?
No.
That is not.
You should just give us a free A in the
Game
class.
You're just giving. Ooh, Lockeretta gift card.
My favorite.
Got me talking.
All right, refocus. How did we get to Lockeretta gift card?
I bring up Mark.
You're not in on it.
Trust me, Lockeretta.
Chips in there.
It's a good thing.
Wait.
You're going to say,
You eat Taco
wait,
Bell every
stop,
day.
wait, stop.
Comes to good.
Convince me.
Lockeretta.
I'm so hungry. I'm just hungry. Tequila.
And by the way, who can read out loud the note right under the word coefficient?
Amount of something.
The amount of something or the count of it, how many there are. That should trigger something in your brain.
Mole.
Say that louder.
Mole.
This is the baseline for where the mole will enter in.
Oh.
Does they have a mold? I don't know.
Very good, Mr. Rest. All right, let's see if you guys can remember some stuff.
We can't.
Hydrogen gas reacts with nitrogen gas to produce ammonia. Somebody in this classroom, or maybe all of us combined, are going to tell me exactly what to write. Is this in the camera angle?
Yeah.
If I stay here, good. Hydrogen gas reacts with nitrogen gas to form ammonia. You should be able to do this equation by telling me exactly what to write.
H2.
H2. Why did you say H2 and not just
Hydrogen
H?
gas.
Hydrogen gas by itself is?
H20.
Diatomic.
It's diatomic. Very good. So now what do I write next? It says reacts with. So what does that mean? What do I put down? I put this plus down. Very good. Nitrogen gas.
N2.
It's N2. Why is it N2 and not just N? When you say, wait a second, when you say iron, you just put Fe. Why am I putting N2? Because it is another one of your diatomic molecules. And ammonia is one of the compounds you're supposed to know. That's ammonium.
Pneumonia.
Ammonia.
Ammonium. I don't know. Ammonium.
So what is ammonia? Thank you. Bennett can say it now. Say it out loud, Bennett. Remember, ammonia is NH3. It doesn't have a charge. It is a stable compound. What is going on? Don't take a man's pencil case. Now, listen.
What are we doing? No, okay.
Listen. This is what you cannot do. I'm demonstrating what you can't do.
Why not?
Now, technically, that is balanced. It has the same numbers on both sides. 3 hydrogens, 1 nitrogen, 1 nitrogen. But this is not chemistry that happens on Earth. So, you can't do that.
Sure I
On
can.
Earth, hydrogen's diatomic, nitrogen's diatomic. So we do know that this reaction happens. So we have to then balance it by changing the coefficients, the amounts of the substance. So now we can change this number. And yes, I know I didn't write a number, but the 1 is assumed. Bennett, what do you think?
You would put a 3 in front of the H2, a 3 in front of the N2, and a 4 in front of the H3.
I like the 3 in front of the H2.
You put it.
That gives me 6. How do I get 6 here?
3.
3.
Still say it.
6, 7.
And
2.
1.
Wait, no.
I think we're done. 6 hydrogens.
Uh-huh.
6 hydrogens.
What about the
And
2 nitrogens
equal
2 nitrogens.
Wait, 2 plus 2 equals 4.
Wait a second. Where are you seeing 3? Remember what this means. Right here. Listen. This means the amount of these. So I'm going to write this over here. It's 1 NH3 and another NH3. Now, if I were to ask you, looking at this, how many nitrogens are total here?
2.
And how many hydrogens?
6.
Okay, so that's what this means here. So, yes, this is now a balanced chemical equation. Now, the only way to get good at these is to actually do them. Yes, Charlotte?
Do those, do they just like cancel out then?
Who did what cancel out?
Oh, did.
Which
The
ones?
H2 and N2. Are those, do those become that other two?
These react together, and actually these amounts to be exact, and it makes ammonia in this amount to be exact. They don't cancel out.
From 3 numbers to 2 numbers.
To 3, you mean 3 entities to just 2 entities?
Yes.
Because it's a completely different substance, and its makeup, how it's bonded together, is different. Notice here, there's 2 hydrogens bonded to itself, 2 nitrogens bonded to itself. On this side, the hydrogen and nitrogen are bonded to each other. And they can only,
How does
this way, because now they are equal. Here, listen, I'm going to read it out loud to what we see. 3 molecules of hydrogen will react with 1 molecule of nitrogen to make 2 molecules of ammonia. And they are all equal.
Can you draw it for
okay,
us?
that makes a little sense.
To a degree, yeah.
Like this
The 3, Charlotte, the 3 in front is acting like
No, not the 3.
Look,
I'm talking about the other
here, and this is not something you would have to do, and you can ask your question, but Jack said, can I draw this for you? And the answer is yes. So up here, hydrogen is a single covalent bond. It's all it can make.
Yes, that
Okay.
makes sense.
And nitrogen, remember, nitrogen has 5 Lewis dots. So you can see that 6 of these electrons are going to be shared, and they'll both have 8. That's called a triple covalent bond. Got it?
Yes, that makes sense.
All right? But there are 3 of these hydrogens that have to react for every 1 nitrogen. Why? Well, because on the other side, this is what's going on. So here is nitrogen again. Here are my hydrogens, and you can see, wouldn't it be nice if they could just come in here, share, share, and share.
They share 3 guys.
That makes a very stable molecule, but it's not just one of them.
There's 2.
That helped me a lot.
There are 2 of these, and here's what's taken place, so that you know.
That makes so much more sense.
Good,
Yeah.
I'm glad.
You should do that more often.
That's like actually.
Well, that's a lot of work for something that's conceptually the same thing. In other words, once you get the concept, you won't have to do all that. But here,
Of the
now if I count all of these atoms up, that actually, what happened is these bonds broke. We just saw that today. We're going to get back to that in a second. And these bonds remade into this. And if we count all of our atoms up, they're all the same. 1, 2, 3, 4, 5, 6 hydrogens and 2 nitrogens on the reactant side. 1, 2, 3, 4, 5, 6 hydrogens and 2 nitrogens on the product side.
there's 2 things of the 3 sharing things.
There's 2 things of the 3 sharing things.
Good job.
Elijah,
Can I use the bathroom?
quickly.
Can you say that's surprise?
How'd I get a 2 in front of what?
The nitrogen, where'd that come from? You made it up here.
What 2?
In front of the nitrogen.
Oh, you can change these. You're allowed to do that.
That's how many groups there are.
In other words, in order for this to be a balanced, that's a good question. Where did the 2 come from? It came from your brain. It actually didn't come from your brain. It came from nature. In order for this reaction to take place, it has to do this because the law of nature says that the amount of mass that you start with in a chemical reaction has to be the amount of mass you end with. So the 2 has to be there, actually. All right, and the last ones, where are we out of time?
Yay! I mean, oh. What about the one outside?
What are we time?
We are at 9:16.
It's
Oh, we got time. All right, I do want to go over what we've done today.
Amazing surprise.
So in the first 5 minutes of class, there were actually 2 chemical reactions that took place, and I do want to discuss them. First of all, I took zinc metal. All right, zinc metal I can show you, but the time restraints today, I'll show you another day.
oh.
And zinc is not diatomic, so when you say zinc, you just put zinc up.
Hey, we got
It reacted with hydrochloric acid. Our rules of naming should tell us what this is, but remember, when hydrogen is in an acid, it acts like a metal, +1. Chlorine is always -1, 1 to 1. So what's the formula?
HCl.
It's just
Now, this is actually a pretty violent reaction. We're going to learn more about this. It immediately starts to bubble and give off a gas. What we find out is that zinc kicks out hydrogen. And again, this is a type of reaction we'll discuss on Monday.
Are you talking about the one that blew up the balloon?
Yep. So zinc kicks out hydrogen and makes a salt, zinc chloride. And it has to be Cl2. Why? Because zinc is a 2+ ion. Chlorine is a 1- ion. To make that formula correct, to crisscross it, you can see it's zinc chloride. And then that boots out the hydrogen. But hydrogen by itself is always what? H2. So in other words, notice what I've done. Look at this. I'm not a human being in this classroom that actually needs to do the crisscrosses for every ionic compound. I mean, I actually know these things before doing it. But as modeling it, this is what you need to do. You have to crisscross to make sure you have the right formulas. Because once you write it correctly, now we can balance our chemical equation if we need to. I hear talking in this corner. So, I didn't know who exactly it was. So, how do I balance this chemical equation?
Let's see. You gotta put a 2 over by the H and that's it.
2 by what H? There's multiple H's.
HCl.
Very good. So if I put a 2 here, that actually does take care of everything. 1 zinc, 2 hydrogens, 2 chlorines, 2 chlorines. We're done.
You're welcome.
Now, here's what I did. In the balloon, I collected the hydrogen gas. And hydrogen gas by itself reacted with what in the air? You saw it. Yeah, that reacted with oxygen in the air. And everybody should know what the wet substance that made the balloon stick to the wall.
H2O.
And that made water, which is also a ridiculously stable molecule on planet Earth. But that's not a balanced chemical equation either. Now, it's written correctly, but it's not a balanced chemical equation. So what would I need to do to balance this chemical equation?
Nothing.
I think we're good now.
You do 2 in front of the O. Oh no.
2 in front of the H.
2 in front of the H.
And 2 in front of the H2O.
If I put a 2 here to make 4 and a 2 here to make 4, I'm happy with hydrogens, and I
Yep.
finally do have my oxygens equal. That is the correct way to balance that chemical equation. Now, we will have plenty of balancing and writing formulas for the final 10 minutes of class. We are done with today's
What's the thing?
Video?
The special thing.